Okay, so it is time for the Unit 2 review. So first they ask us to solve the square roots given below. Well, the square root of 196. I could just type that in my calculator and get an answer. And if it's a whole number, then we're good. So let's see, square root of 196. We're good, it's 14. This is going to be just 14. The square root of 100. Let's say you didn't know that one. Type it in. You get 10. So those are just straight up, you can do it in your calculator. But then 2, where it says simplify the following, we can't do these in the calculator. I mean, look what happens if I do the square root of 18. It's going to give me a decimal. I do not want 4.2426. Oh, I don't want all that as your answer. I want you to simplify the radical. So remember, this is where we have to find a perfect square that goes into each of these and go from there. So like 18. What are two numbers where one of them is a perfect square that multiplies to give you 18? Well, we could do 2 and 9. 9 times 2. That breaks up to the square root of 9 times the square root of 2. What's the square root of 9? 3. And then I'm left with the square root of 2. B is asking about the square root of 48. Well, if I think about my perfect squares, I want the largest perfect square that goes into 48 evenly. 36 certainly doesn't. 25 won't, but 16 will. 16 goes into 48 3 times. So then break it up. This is going to be the square root of 16 times the square root of 3. The square root of 16 is 4, and then I'm just left with that square root of 3. Then we have the square root of 72. So let's say you didn't know. You're kind of at a loss. Let's see 72 divided by 2. See what that gives us. Oh, 36. That's a perfect square. 36 and 2. So this is going to be the square root of 36 times 2. Let's see, that's going to leave me as a square root of 36 times the square root of 2. Square root of 36 is 6. The square root of 2, well, I just bring that down. Okay, the square root of 243. Well, I can't divide it by 2, but maybe let's try 3. 243 divided by 3. 81 is a perfect square. So this is going to be the square root of 81 times 3. It's going to be the square root of 81 times the square root of 3. Square root of 81 is 9. And then we've got the square root of 3. Okay. Now for the fractions. A lot of y'all tend to like the fractions better. Y'all say, oh, these are easier. And they could be. We can't leave this radical on the bottom. So I need to multiply the top and the bottom by whatever that radical is. So in this case, it's going to be the square root of 3. On top, it's going to give us 9 square roots of 3. On the bottom, I remove the radical, and I'm just left with a 3. 9 divided by 3, because I remember, you want to always try to reduce. 9 divided by 3 is 3, and then I have that square root of 3. What about the next one? Well, on the next one, I've got this square root of 2 on the bottom. So I do the square root of 2 over the square root of 2. On the top, you just bring them together, 5 square roots of 2. On the bottom, you take off the radical. You can't reduce 5 over 2, so you're done. For G, the square root of 2 is on the bottom. So I multiply that on top and bottom. I get 8 square roots of 2 over 2. I want to look to see if I can reduce. Can I divide 8 by 2? Yes. That gets me 4 square roots of 2. And then for H, square root of 3 over the square root of 3. Then get me 18 square roots of 3 over 3. I want to see, can I reduce 18 over 3? Yes, I can. This is going to give me 6 square roots of 3. Okay, number 3. They want us to find the missing sine lengths using the Pythagorean theorem. This will scroll. That's weird. Find the missing sine lengths using the Pythagorean theorem. Simplify the radical. Also, decide if the side lengths form a Pythagorean triple. Remember, a Pythagorean triple is one where all 3 are going to be whole numbers. So let's look at number 3. First thing we need to do, label your C. There's your C. That's when we do the Pythagorean theorem, it's just a squared plus b squared equals c squared. That's the side that goes by itself. Let's see, this is going to be 30 squared plus 40 squared equals x squared. 30 squared is 900. 40 squared is 1600. 900 plus 1600 is 2500. Square root it, and we get x equals 50. Now, is this a Pythagorean triple? It is, because they're all whole numbers. This is a Pythagorean triple. Okay, number 4. Again, remember, label your C. There's a C. So it's going to be by itself. X squared is going to be by itself. 6 squared plus 9 squared equals x squared. 6 squared is 36. 9 squared is 81. Together, that's going to give me 117 equals x squared. Now, when I take the square root here, it's telling me to just simplify the radical. In other words, don't just give me a decimal here. Simplify the radical. I don't just want a decimal. So let's see what I can do with 117. Maybe I can divide it by, I can't divide by 3, maybe, sorry, I can't do 2, maybe 3. Nope. Well, I can, but that's not gonna do me any good. Let's try 9. 9 and 13 work. So this is going to be the square root of 9 times 13. Square root of 9. Which, again, we can break this up. Square root of 9 times the square root of 13. Square root of 9 is 3. And then I can't take the square root of 13. So x is 3 square roots of 13. And that's as simplified as we can get. Okay, this is not a Pythagorean triple because, yeah, they're not all whole numbers. Number 5, decide whether the side lengths can be a triangle, and then if so, classify them as acute, obtuse, or right. So first, we need to add the smallest 2 sides and see if it's together, they're bigger than the largest side. So 9 plus 12 gives you, let's see, 9 plus 12. It's going to be 21. Is 21 greater than 16? It is, so it can be a triangle. Now we need to do the smallest 2 here. So 1.5 plus 3.6. It's going to give us 5.1. Is that greater than 3.9? It is. So that one counts. Okay, so then let's look at C. Need to do 11 plus 14. Together, that gives me 25. Is that greater than 27? No. So this one is not a triangle. Okay, so C is done because C is not a triangle. But what about A and B? We have to figure out whether it's acute, obtuse, or right. So now I need to do 9 squared plus 12 squared and see how that compares to 16 squared. Let's see. 9 squared plus 12 squared. That's going to be 225. 16 squared, I know, is 256. Which one's bigger? The C squared is bigger. When that happens, when C squared is bigger, this is going to be obtuse. Okay, so now let's look at B. I have to do 1.5 squared plus 3.6 squared and see how that compares to 3.9 squared. So 1.5 squared plus 3.6 squared, 15.21. Okay, 3.9 squared, 15.21. Well, what do we notice about these? They are equal. Which one's equal? It's a right triangle. And then we already said C is not a triangle. So there's that one. Now for 6 and 7, we have to use the Pythagorean theorem to find the length of the missing sides and round to the nearest tenth. So I know you can't really see it on number 6, but our X is down here. So remember, we want to label our C. There's the C. It's what goes by itself. So we're going to do 7 squared plus x squared equals 25 squared. 7 squared is 49. 25 squared is 625. Subtract the 49 to the other side. Get x squared equals 576. Square root both sides, and you get x equals 24. Okay, number 7. Again, label your C. The C is across from the right angle. There's your C. That's 8. So 6 squared plus x squared equals 8 squared. It'll be 36 plus x squared equals 64. Subtract the 36 over. We're going to get x squared equals, I think, 28. Yep, 28. And then I have to take the square root. So x is going to equal square root of 28. This time it does want us to round to the nearest tenth. So 5.5 3. So just make sure that you follow the directions. Here it does say round to the nearest 10th. Okay, number 8. We're still dealing with the Pythagorean theorem, but this one's going to be a little tricky because they want you to find x, but x is the whole bottom down here, and this isn't a right angle, so you can't say 7 squared plus 10 squared. No, you have to do these separately. So I'm going to do the left triangle first. I'm going to call that side, I don't know, maybe like a y. That way I don't get it confused with my x that I'm finding. And so where's your C on this one? It's going to be that 10 out there. So I'm going to do 6 squared plus y squared equals 10 squared. 6 squared is 36. 10 squared is 100. Move the 36 over. Get y squared equals 64. Square root it, and you get y equals 8. There's your y. So there's this piece right here. This piece is 8. Now we have to focus on the other side. We've got to do this side now. Maybe we call that side, I don't know, Z. So in that case, our 7 is the C. So we've got to do 6 squared plus Z squared equals 7 squared. 36 plus, wait, not squared, 36 plus Z squared equals 49. Move the 36 over. We're going to get Z squared equals 13. Square root that, and we get Z equals, it's going to be 3 point something. It says round to the nearest 10th, so when I take the square root, I'm going to round to the nearest 10th. 3.6. Okay, so now I know this part's 8, this part is 3.6. So how do I get all of x? X is going to be 8 plus 3.6, which is 11.6. There we go. This one had a little bit of work in it, but it was still doable. Okay, next one. These next 4, we have to do special right triangles. So remember our steps for those. First, you want to label your legs. So on number 9, I'm going to label my legs. Then you want to label your template. Well, this is a 45-degree angle right here. So that means this is a 45, 45, 90 special right triangle. That means each leg is x. And the hypotenuse is going to be x square roots of 2. Then you want to solve for x? Well, 26 equals x. So this side, I'm going to put a 26 there because that's what x is. Here, I'm going to put a 26 square root of 2 because that's what x is. So this means that b is equal to 26 and c is equal to 26 square roots of 2. Okay, number 10. Again, it's a 45, 45, 90 triangle. So label your legs. And then we can label our template. X, x, x square roots of 2. Now that's going to make a little equation where they have the 22 right there. So I need to divide both sides by the square root of 2. Those cancel. So x is 22 divided by the square root of 2. Now, I can't leave it like that. I can't have that square root of 2 on the bottom. So multiply the top and bottom by the square root of 2. It's going to give me 22 square roots of 2 over 2. I can reduce 22 over 2, get 11 square roots of 2. So that means a, or this x, then has to be 11 square roots of 2. This x is 11 square roots of 2. So what's a? A has to be 11 square roots of 2. That's 45, 45, 90. Then they ask us about 30, 60, 90. Okay, so still our first step is the same. Label your legs. There's our right angle. There's a leg. There's a leg. Since this is a 30, 60, 90 right triangle, the short leg is x. The long leg is x square roots of 3. And the hypotenuse is 2x. Now find your x. Well, here's the side they give us. This says x equals 12. So any place I see an x, I'm going to plug in a 12. 2 times 12 is 24 up there. 12 square roots of 3. So that means b is going to be 12 square roots of 3. C is going to be 24. Okay, number 12. Again, first step, label your legs. Okay, now that we've got our legs labeled, let's do our template. It's a 30, 60, 90. So the short leg is going to be x. The long leg is going to be x square roots of 3. The hypotenuse is 2x. This gives us a little equation here. 2x equals 32. So divide by 2, and you get x equals 16. So anywhere you see an x, x is 16. So what's a? A is 16. B, 16 square roots of 3. Okay, number 13. 13 is asking us which parts of a right triangle are needed for each of the following: sine, cosine, and tangent. Well, that's dealing with our trig ratios. So to remember those, we used an acronym. We did SOHCAHTOA. SOHCAHTOA. So for sine, what do I need? I need the opposite leg over the hypotenuse. For cosine, what do I need? I need the adjacent leg over the hypotenuse. And then for tangent, what do I need? O over A. Opposite leg over the adjacent leg. Okay. 14 is giving us the ratio and then asking which one is it? So which one is opposite leg over hypotenuse? This is sine. Opposite leg over adjacent leg, O over A, is going to be tangent. And then adjacent over hypotenuse, A over H. It's going to be cosine. Okay, so 15. Now we want to get practice just punching it in the calculator. So sine of 43. Trig sine 43. To the nearest hundredth or 2 decimal places, it's going to be 0.68. Remember, I forgot to mention this, but remember, make sure your calculator is in degree mode. Mine is, so we're good. Cosine of 28 degrees. 0.88. And then tangent of 31. 0.60. Okay, for 16, write each trig ratio as a fraction and a decimal to the nearest hundredth. So if I'm doing the cosine of h, what do I need for cosine? I need adjacent over hypotenuse. So if I'm standing at h, which one's adjacent to h? That would be the 15. And then which one's your hypotenuse? 17. So this one would be 15 over 17. So I'm just going to type that fraction in. I'm not going to hit trig, just the fraction, and then control enter. It's going to be 0.88. Then they asked me about the sine of h. So I'm still going to be at h, but I want the sine now. So that's going to be the opposite over the hypotenuse. So which leg is opposite of h? It's going to be kj, or 8. So 8 over 17. Then I need that as a decimal. 8 divided by 17.47. And then they want the tangent of angle K. So now I'm going to go to K. I'm not at H anymore. I'm going to K. Tangent, I need opposite over adjacent. So which one is opposite of K? That's going to be the 15. Adjacent to K is the 8. So that means this is going to be 15 over 8. And that as a decimal, 1.88. Okay, 17. They want us to use the trig ratio to find the length of RS. RS is right there. Well, let's see. That's the side I want. Circle the angle they give you. Then let's see, how does that X compare to the 27? It's opposite. What about the 5? That's adjacent. So which one uses opposite over adjacent? It's going to be tangent. So let's set it up over here. Tangent of 27 equals X over 5. Multiply by 5 on both sides. It's going to cancel. I'm going to get 5 times the tangent of 27 equals X. X is by itself, so I can plug into the calculator. 5 times the tangent of 27. 2.55, basically. So X is 2.55, and then we're going to be in feet. Okay, 18. Again, use the trig ratio to find the missing side. Here's our missing side, this X right here. So circle the angle they give you. How does the 18.3 relate to the angle they give you? It's adjacent. What about the X? The X is going to be our hypotenuse. So which one uses adjacent and hypotenuse? Cosine. So the cosine of 47 degrees is equal to 18.3 over X. Multiply by x on both sides. Those will cancel. I'm going to have x times the cosine of 47 equals 18.3. Divide by the cosine of 47. Those cancel and gets me x equals 18.3 over the cosine of 47. Let's see what that is. 18.3 divided by the cosine, not plus, I'm about to really mess up here. Divided by the cosine of 47. No, I'm still. $26.83. Is it 83? Yeah. And this doesn't have units, so we're just gonna leave it like that. Okay, so now we're going to talk about trig inverses. So these next three, they just want you to type them straight in the calculator. So the tangent inverse of 3.5, 74 degrees. Now they want us to run to the nearest degree, so it's just going to be 74 degrees. Sine inverse of 0.43, 25 degrees. And then cosine inverse of 0.08. $85 degrees. Okay, number 20. Find the measure of angle A to the nearest degree. And they give us a hint. Use the trig inverse. So A, where is A at? A is right there. How is that 3 related to angle A? It's adjacent to it. The 5 is your hypotenuse. Which one uses adjacent and hypotenuse? Cosine. So I need to do the cosine inverse of the adjacent over the hypotenuse. So trig, cosine inverse, what was it going at? 3 divided by 5. 53 degrees. And 21, find the measure of angle A to the nearest degree. So where's A? A is right there. So how does the 5 relate? 5 is opposite. The 13 is your hypotenuse. So which one uses opposite and hypotenuse? Sine. So it says use a trig inverse. So I need to do sine inverse of 5 over 13. 23 degrees, basically. Okay, that's doing trig inverse. Still got another one. To the nearest degree, what angle does a hill make with a grade of 22% with the horizontal line? So the angle we're wanting to find is this one down here. So this 22 out here, that's going to be opposite. The 100 is adjacent. Which ratio uses opposite over adjacent? Tangent. They give us a hint, use a trig inverse. So the tangent inverse is opposite over adjacent. $12 degrees, because it says the nearest degree. So this will be 12 degrees. And 23, classify the numbered angles as an angle of elevation or an angle of depression. Remember, you want on these, you want to go from the dotted to solid. So you go from dotted to solid. So angle 3, he's looking down. Which one is that? That's an angle of depression. Angle 4, he's looking up. So that's an angle of elevation. Okay, so even though the picture doesn't look like it, a secret admirer in a blimp cites Mary Beth at Kyle Field, which is A&M's football stadium, at an angle of depression of 34 degrees. The blimp's altitude is 1,600 feet. What's the horizontal distance from the blimp to the stadium? So they actually were nice enough to give us the triangle to focus on. Okay, so 34 is our angle down here. How does this x relate to it? It's adjacent. What about the 1,600? It's opposite. So which trig ratio uses opposite and adjacent? Tangent. So we're going to have the tangent of 34 degrees equals the opposite, which is 1,600 over x. Multiply by x on both sides. So we have x times the tangent of 34 equals 1,600. Divide by the tangent of 34. Those cancel. And this is going to give you 1,600 divided by the tangent of 34. 2,372. 2,372 feet. So while Mary Beth is at the Aggie football game, John Paul is diving in Lake Bryant at a depth of 63 feet below the surface. He spots a buoy floating at the surface at an angle of elevation of 47 degrees. How far must John Paul swim so that he is directly beneath the buoy? Round to the nearest foot. So again, they give us the triangle. So let's see, there's our angle. How is this x related to the angle? It's adjacent. What about the 63? It's opposite. So then, which one uses opposite and adjacent? Tangent. So this is going to be the tangent of 47 degrees equals 63 over x. Multiply by x on both sides. X times the tangent of 47 equals 63. Divide by the tangent of 47. Those cancel. 63 divided by the tangent of 47. 59, if I round to the nearest foot, it's going to be 59 feet. That's how far he has to swim until he's right underneath it. Okay. 26, moving on along. Find the value of x. Give your answer in simplest radical form. Okay, so let's see. Here's our x right here. I can't just jump in and find it because this triangle that it's on only has one side. So first I have to find what this side is. So let's see. I'm going to use a small triangle and get, let's just call this y. To get y first. Well, there's the c. So 7 is my c. So let's see. 2 squared plus y squared equals 7 squared. Okay, well, it's going to be 4. Subtract the 4. Get y squared equals 45. Square root it. And since this is just an intermediate term, I'm just going to leave it as a square root of 45. And come in here and plug it in right there. I'm just going to leave it there because it's not my final answer. It's something I need for my final answer, but it's not my final answer. So there's that piece. Now, that's going to be my c when I get my x. So 5 squared plus x squared equals the square root of 45 squared. It's going to be 25 plus x squared equals 45. Subtract the 25. You get x squared equals 20. Square root it, but before you say it's 4.5, remember what the directions say. The directions say in simplest radical form. So let's see, I know I can do 20 is square root of 4 times 5. Be square root of 4 times the square root of 5, which is 2 square roots of 5. So that's my x, 2 square roots of 5. Okay, so up until this point, we've dealt with pretty much nothing but right triangles. So now let's grab the first day of the unit that we haven't really talked about yet. So let's do the first day. So now we're just going to be talking about triangles in general. 27 asks us to classify the triangles based on the angle measurements. Based on angle measurements. So remember, our options are equiangular, right, acute, or obtuse. Those are our only options. So here I see one that's 18, 40, and 122. Does any angle jump out at you? This 122 is what kind of angle? It's obtuse, so that makes this an obtuse triangle. $35, $90, and $55. Anyone jump out at you? 90. That makes this a right triangle. $28 says to classify the triangle by its angle measures and side lengths. Now, one of these triangles can go 4 ways, so we've got to make sure we do all 4. Let's do angle measures first. So if I look at A, they're all 60 degrees. So this is going to be equiangular. But if it's equiangular, it also has to be acute. Now let's do the angles on B. I see this 135-degree angle. That means this one is obtuse. And then for C, I see a right angle right here. That means this one is a right triangle. Now let's go by side lengths. So for A, all sides are the same. That means this one is an equilateral triangle. If it's equilateral, though, it also has to be isosceles. Okay, next one. None of the sides are the same on B. If none of the sides are the same, it is called a scaling triangle. And then for C, 2 sides are the same. That means it is isosceles. We're getting to the end, almost there. Okay, 29 asks us to find the third angle. Find the third angle. Remember, all triangles have to add to equal 180. So to get the third angle, I can add the two they give me. So 23 and 88, add those. Give me 11, carry my 111. And then I'll subtract that from 180. $69. This one, this other angle has to be 69 degrees. On the next one, I add them together, 43 plus 47. And that gets me 90. Subtract that from 180. And I'm left with 90. So this one's going to be 90 degrees. Now, on 30, can the given angle pairs be from a right triangle? Well, we have to see if they add to equal 90, our answer is yes. If they don't equal 90, our answer is no. So 21 plus 73. What does that give us? It's going to give us 94. Does that equal 90? No. What about 34 and 56? 10, carry your 1, 90. So does this equal 90? Yes. Okay, last one. We have to deal with exterior angles and the remote interior angles. I know it's been a hot minute since we've talked about those. So remember, the one outside is your exterior. The inside two are going to be remote interior. The relationship is that if you add these two together, it equals your exterior. So 37 plus 55 equals x. $37 plus 55. 92. So that means x equals 92. Okay, and then C. Here's our exterior angle. These are the two remote interior. So I add those together. It's going to give me 5x plus this box means 90. 5x plus 90 equals 20x minus 15. I've got to find the x. Move the 5x over. I mean 90 equals 15x minus 15. Add 15. It's going to get us 105 equals 15x. Divide by 15, and we get x equals, let's see, 6, I think 7. Let me double check. Yep, 7. So x equals 7. Okay, so there's the review for Unit 2. Study it, know it, and good luck on the test tomorrow. But more than anything, remember, I can try. Oh. Remember, you are awesome. and you were created to do great things. Always believe.